Good evening everyone. So we'll be discussing about equilibrium. So in the last class we have completed up to salt hydrolysis, right now. So pH of salt hydrolysis. So tell me, how can we find pH of a salt solution that is formed by combination of weak acid plus strong base? What I am saying? Weak acid, a salt of weak acid plus strong base. Give one example.
7 plus.
Give one example for this first.
Weak acid CH3CO.
So weak acid combination with strong base means NaOH. So sodium acetate salt will be the best example here we can take. Okay. So now what is the pH of this salt solution? If I take the solution of this salt, what will be the pH? How can we calculate that? pH will be equals to 7 plus half into
pKa minus
weak acid is there now, so take its pKa. So pKa plus log C. C is the molarity here. Okay, and the next tell me, if the combination of a strong base, a salt formed by combination of strong base and a weak acid. Strong base, weak acid is over. Weak base and a strong acid. Tell me for this
7.
example first. Weak base plus a strong acid.
weak base
Weak base, here we can take ammonium hydroxide
NH4
plus HCl. So this solution, this combination will give us NH4Cl. So the pH of this NH4Cl solution, if this NH4Cl salt kept in water, it will undergoes hydrolysis. Now during that hydrolysis, what is the pH? How can we calculate pH of that salt solution?
7 minus
7 pH. Strong acid now, so resultant solution upon hydrolysis also it will be acidic. So 7 minus half into pK what?
pKb.
Weak base involved now, so pKb plus log C, that's it. And one more formula I have for combination of salt formed by weak base plus weak acid. So like sodium, ammonium acetate we can say, like ammonium hydroxide plus acetic acid. So now pH of that combination will be calculated using 7 plus half
pKa minus
pKb. This is what we have discussed and few numericals related to this. I think 1 or 2 questions are given as a work also right now. So now in this session we will be discussing very important topic, that is common ion effect based on Lee-Chatterjee principle, and the next buffer solutions. Okay, so let's begin the session with common ion effect first. So now tell me what exactly common ion effect means. See, common ion, name itself saying a common ion. For example, look at here. So I have a weak electrolyte, let us say for understanding purpose I am taking weak acid, acetic acid I am taking. So this will dissociates to give acetate ion plus H plus ion. So tell me whether it is weak electrolyte or strong electrolyte? Weak electrolyte. So now to this weak electrolyte I am adding a strong electrolyte, something like sodium acetate. So sodium acetate is a salt now, acetate ion plus Na plus ion. So this is strong, it is a strong electrolyte or weak electrolyte, tell me? Strong electrolyte. This salt is a strong electrolyte. So now strong electrolyte will undergo complete dissociation to give respect to ions, sodium acetate ion plus sodium ion, right now. So now what I have taken? I have taken a beaker. So in this first I have taken a weak electrolyte. This weak electrolyte I have taken. This solution of weak electrolyte. It will undergo dissociation like this. After undergoing dissociation to some extent, equilibrium is established. Okay. So to this equilibrium, what I am adding now? Strong electrolyte. Now look at the strong electrolyte once. Strong electrolyte is having an ion common with this weak electrolyte. Yes or no? So now what happens? Whenever we add a strong electrolyte having common ion with this weak electrolyte, the degree of dissociation of weak electrolyte will be decreases. Why it is decreases? We have studied Le-Chatillon principle. So what it says, Le-Chatillon principle says, see, if concentration of reactants is increased in an equilibrium reaction, equilibrium moves forward. If concentration of product increased, so reaction moves, equilibrium moves backward. So now by adding strong electrolyte, we are getting acetate ions. The concentration of acetate ion in the beaker
Is
increased. Therefore, equilibrium moves backward. Therefore, degree of dissociation of this weak electrolyte is decreased. Is that clear or not? So, what is the basic definition we can write? Common ion effect means the degree of dissociation of alpha of a weak electrolyte is further suppressed. Why I am using word further here? Suppressed, because we know weak electrolyte dissociate to very small extent now. Again that will be suppressed. It means that is decreased. That is what? Further suppressed by addition of strong electrolyte having common ion with the weak electrolyte. Is this definition is clear or not? Okay, so this is a weak electrolyte. It will only dissociate to some extent. To this, if I add a strong electrolyte, what happens? The degree of dissociation of this electrolyte will be decreased, or I can say it equilibrium moves backward. That is nothing but degree of dissociation of this weak electrolyte is decreased. That's it. So now one more thing you need to understand when it comes to numerical purpose. Look at here. I am saying I am taking this electrolyte, this weak electrolyte, initially with C concentration. How much concentration? C. And these are 0, 0 initially at time t0 beginning. So after equilibrium is attained, C minus some, instead of saying C alpha I am saying X. So this will be formed is X and X. Now this will be the condition at equilibrium state. That's what T equilibrium means in this beaker. To that I am adding this strong electrolyte. So now strong electrolyte concentration, let us say how much will take? Will take some 0.5 concentration will take. Some numerical value I am taking. So 100% dissociation means this ion also 0.5, this ion also 0.5. Now what is the total concentration of acetate ion in the beaker? What will be your answer? X plus 0.5, because two ions are there here. Acetate ions are from here and here. So total concentration of acetate ion will be X plus 0.5 you will be writing. But you know what happens? What is the common ion effect definition I given?
the depression
of weak electrolyte by
Addition of strong electrolyte. So now the suppression will take place to that amount when we compare the concentration of this ion from weak electrolyte with this ion from strong electrolyte. The concentration of that ion from weak electrolyte is almost negligible. It means X plus 0.5 value will be taken as just 0.5 only. It means the concentration of this acetate ion coming from weak electrolyte is almost negligible when I compare with that ion concentration from strong electrolyte. Is this clear or not? X plus 0.5 means what I am writing now?
0.5.
So from where that 0.5 is coming? That is purely from
Strong electrolyte.
That's it. Is this clear or not? Right. So one more point also you should know, write a note point. The concentration of ion formed from weak electrolyte which is not in common with strong electrolyte is the concentration of weak electrolyte concentration of ion formed from a weak electrolyte which is not in common with strong electrolyte is decreases or decreased. It means what it is saying, tell me. The concentration of ion formed from weak electrolyte, these are the two ions formed. That ion which is not in common with the strong electrolyte, which ion is not in common here? H plus ion. So its concentration will be
Decrease.
Why it is decreased? Because
Our reaction is not taken.
it is undergoing backward side, like degree of dissociation is decreased, it means going backward equilibrium. So H plus ion concentration will be decreases. Why I am specially mentioning H plus ion concentration? Because acetate ion concentration can be balanced or managed from this strong electrolyte, but for this weak electrolyte no one is to help, therefore its concentration will be decreased. That is what I am saying here. Okay, so you can expect a statement based questions in the here also based on this. Okay, right. Now this common ion effect applicable only for weak electrolytes. What I am saying? Common ion effect concept is applicable only for why only weak electrolyte? Just look at the definition, degree of dissociation alpha, it's decreased. For which electrolytes? Only for weak electrolytes. Why? Because for strong electrolytes, whatever may be the condition, alpha will be always, degree of dissociation will be always 100%. Yes or no? For strong electrolytes, degree of dissociation is
100%.
but for weak electrolytes only the value will be varies. Okay, so common ion effect applicable only for weak electrolytes. Is this clear or not? Right. Now I am asking you a question. Tell me answer for this. If you answer this properly, I can consider that concept is clear. Okay. So now for ammonium hydroxide solution, by addition of first of all tell me ammonium hydroxide weak electrolyte or strong? Weak electrolyte. By addition of NH4Cl, ammonium chloride, tell me it is strong electrolyte or weak electrolyte? Ammonium chloride salt, strong electrolyte. Ammonium chloride, the pH or the concentration of OH minus ion dash happens. Concentration of OH minus ions decreases or increases? You tell me here. Is my question is clear or not? For ammonium hydroxide solution, by addition of ammonium chloride, the concentration of OH minus will be decreases or increases?
Decreases.
Huh?
Decreases.
Why it is decreases?
Because the node point just now.
Just now I told you what? If this is a weak electrolyte, it will dissociate to give ammonium cation plus OH minus ion. Here this is strong electrolyte having common ion with this, therefore degree of dissociation decreased, therefore OH minus ion concentration decreased. Concept is clear now. So now what happens to the pH? If concentration of OH minus decreases,
pH also
decreases. Is that clear or not? So pH also decreases. So you can expect statement based questions here, right? Clear now? Yes. The next thing is one more thing I am asking. Wait a minute. So look at here, by addition of, be conscious while answering, addition of small amounts of NaCl crystals to HCl solution, the concentration of H plus ion will dash happens, decreases or increases?
Nothing. Huh. Nothing, because it still dissociates completely.
Nothing happens here, no change, no effect. Why no effect? Be conscious, that's why I told you.
HCl
Because
is a strong
HCl is a strong electrolyte. What we are adding? Small amounts of crystals. Okay, see HCl already it will undergoes complete dissociation right now, like this. By addition of NaCl, this will also undergo dissociation. But is there any effect of this? Why? Because I told you common ion effect applicable only for weak electrolyte. For strong electrolyte already it is 100% dissociated. So is this clear? This question is also like understandable one right now. Next. we will be discussing buffer solutions based on the understanding of common ion effect. Now common ion effect is clearly understood using Lee-Chatterjee principle, because here you have told now concentration of product increases means reaction goes backward, reactant increases means reaction goes forward, like this. Okay, so now let us understand buffer solutions. See, buffer solutions are very important, and especially for bio students. Why? Because you just tell me, I have a pure water in a beaker. To that, if I add lemon juice, what happens? That beaker water becomes acidic, right now. So pH of that water will be changing here. Right now, it is becoming acidic. Now, I am giving a glass of lemon juice to you. Now you will take the juice, you will drink that. Now what about your body pH?
Same.
Will it changes? No, it will not change. It will remain same. So if there is any change in body pH, that is very dangerous to health, but it is not changing. It means there is something in your body, there is some system in your body which is resisting the change in pH. Those systems or those solutions or those compounds which are present in your body, which are resisting the change in pH, are considered as buffer solutions. What are those? So it means, what is the best or simple way to define buffer solutions?
Sorry, example.
What is the best way to define the buffer solution?
The solutions which resist any pH change.
The solutions which resist change in pH by addition of small amounts of strong like acid or a base or upon dilution. So finally what it should happen? Resistance of pH should C. Okay. So now how can we make these buffer solutions? We need to know right now. So now first of all, types of buffer solutions, we have two types. One is before going to that, one is normal buffer or simple buffer, I can say. Other one is mixed buffer. What I am saying? Mixed buffer. So this mixed buffer, again two types. One is acidic buffer and other one is basic buffer. This normal buffer or salt buffer, I can say normal buffer or salt buffer. So salt buffer only one I can given, but mixed buffer are two. Acidic buffer, see name itself saying mixed buffer. It means when these buffers are forming, there is a combination of two things are there. It means our resultant solution contain two compounds, mixture of compounds. But here this salt buffer contains only one solution. For example, it is a solution or this is a buffer solution formed by combination of weak acid plus weak base. It means simply a salt of, what you can say, simply see acid plus base becomes what? Salt formation takes place, salt plus water. So it means I can write simply this is a salt solution of
Weak acid and weak base.
salt solution of weak acid plus weak base. It means salt solution of weak acid weak base means, example you give me, weak acid acetate ion, ammonium ion from ammonium hydroxide, strong base. So the solution of this is a simple one compound or not, single compound or not. So that is a salt solution or a salt buffer or a normal buffer. Now what is the other thing I told you? Acidic buffer. So look at here acidic buffer and basic buffer carefully. So acidic buffer, so now on what basis we have differentiated them? Types of buffer means it depends upon based on composition. What is that? Composition. Now look at the acidic buffer means it is a mixture of weak acid and it's a salt with a strong base. Once again, weak acid and it's a salt with a strong base. It means, look at here, give me one example of weak acid. Acetic acid is the best simplest example everyone knows. Okay, and along with this I am taking a strong base, NaOH. Now weak acid, weak acid and a strong base. So simple acid base reaction takes place. So tell me what is the resulting solution will be? Na plus plus H2O will be there right now. So look at here, if I take 1 mole of this, 1 mole of this, how much amount of salt is formed?
1 mole.
That is also 1 mole, like this right now. So but what I told you, acidic buffer means acidic buffer. The name itself saying buffer is
Acidic.
it means acidic composition should be major. So it means by taking this little excess than this base, what happens? Instead of taking 1 mole to get 1 mole, if I use 2 moles here I am using only 1 mole, then resultant mixture will contain what? How much amount of salt is formed?
1 mole.
Because this is limiting reagent. So whenever we are seeing acidic buffer, what should be the limiting reagent? Strong base should be the limiting reagent. That should be limited quantities, less quantities. Okay, so we will be getting here 1 mole. Out of this 2 and 1, so 1 mole is reacted with this and 1 mole remained unreacted. So it means resultant solution will be containing what?
1 mole.
1 mole acetic acid.
1 mole acetic acid.
This base is 0, no, nothing, and 1 mole
Acetic acid
salt.
salt. Sodium acetate.
What is this name of this salt? Sodium acetate is fine. But how that is formed? This salt is a combination of this weak acid
Strong
plus
base.
strong base. Now resultant solution is having what we have in resultant solution?
Weak acid.
Weak acid, and it's salt with a
Base.
it's salt with a
Base.
strong base. Once again, weak acidic buffer means weak acid plus salt of
Strong base.
this weak acid with a strong base. That composition is considered as acidic buffer. Is this clear or not? Right. Can you give me 2 or more examples, like 1 or 2 examples like similar to this?
C2H5COOH.
Like oxalic acid we know, no?
COH.
Oxalic acid we know, no? COOH, COOH.
Tartaric acid.
Or tartaric acid you can take. Oxalic acid is okay, best example here. Okay, so now I am treating this with a NaOH. So now what I told you, weak acid plus buffer solution to construct weak acid plus its salt with a,
Strong base.
so it means like this. So this mixture is what? It is also a
Buffer. Acidic buffer.
simply in the exam they will be giving us 4 options will be there. Identify buffer solution from the following or acidic buffer from the following. What should be the primary criteria you need to look for?
Weak acid.
It should be a combination of weak acid plus
Strong base.
salt of that weak acid with a strong base. That's it. Okay. So now instead they will give these 4 options. See, which are the following forms a buffer solution or acidic buffer? By giving, see, what is the criteria we need to look for? Which one should be the limited and which one should be the excess?
Excess weak acid.
In order to form acidic buffer, weak acid should be excess quantity, strong base should be limiting quantity. Always strong base here should be limiting quantity. Clear or not? Just look at the number of moles given and identify which solution will form buffer solution, which mixture will form buffer solution. Clear or not? Next, we'll be giving, right. Now, you got acidic buffers now. In the same way, define basic buffer.
Weak base. Weak base is salt of its strong acid.
Weak base
Huh?
and it's salt with a strong acid.
Tell me.
Weak base and its salt is a strong acid.
Weak base
And it's salt with strong.
and it's salt with a strong acid. So give one example.
NH4OH weak base, strong acid.
NH4OH is a weak base.
H2SO4.
Plus take HCl or H2SO4, that is fine. So strong acid, weak base plus a strong acid. So which should be major quantities here?
Weak base.
Tell me.
Weak base.
Again, limiting quantity should be
HCl.
HCl. So like it should be something like, this should be 2, this should be 1. Even I can take, this is 1.5 and this is 1 also. Or this is 1.2 moles, this is 1. Even small quantity of that must be excess quantity. What must be excess quantity? Weak base should be excess quantity here. That's it. Clear now? Right. Next. Now finding the formulas or calculating or understanding the formula of pH for this. See. Here we have written so in the acidic buffer, first of all we will study about acidic buffer. Tell me what is its combination once again? Weak acid plus
Acidic buffer, weak.
tell me.
Acidic buffer, weak acid plus salt of weak acid with
Strong base. Okay. So weak acid means acetic acid you have taken previously. So now also we will consider same thing. So it will dissociate to give H plus acetate ion. Now acid dissociation constant, what we can write? Ka is equals to concentration of H plus ion, concentration of acetate ion by concentration of acetic acid. Like this we can write. Now what I want is, I want concentration of H plus ion. I can write Ka into concentration of acetic acid by concentration of acetate ion. Like this we can write. Up to here it is clear. Now look at here. Just now we have studied common ion. So common ion effect we will use here now. So once again tell me, acidic buffer means it's a combination of weak acid
plus its salt with strong base.
its salt means acetate ion
COONA.
with sodium hydroxide, sodium ion.
Hydrolysis CH2O.
So it will give acetate ion plus
Sodium.
ion right now. So what is common here?
CH2CO.
These things are these things are common. Now due to common ion effect, what happens to this?
Backward reaction increases.
Now you need to understand buffer action here, how this solution is acting as a buffer. Right now, just now you need, like you got to know, this is a buffer solution example, acidic buffer solution. But how it is resisting change in pH, you need to know right now. See, for example here, I am increasing the concentration of H plus. See, I have a buffer solution. To that, I am adding little amount of H plus ion. Now what should happen normally?
Acidic nature decreases.
It should happen normal solution, but it is buffer solution now. What happening is there is no change in pH. Why? Because whatever the H plus ion you are adding, that H plus ion constant, see this is equilibrium now. If concentration of H plus ion is increased, what happens to equilibrium? Goes backward. So it is just adjusting its equilibrium. Is there any change in pH now? No. Just equilibrium is getting adjusted. If you increase the concentration of H plus ion, equilibrium moves backward. Now instead of doing this, by adding OH minus ion, what happens?
Forward reaction.
If OH minus ions are added, now this H plus ion, whatever you have added OH minus ion, that is consumed by this H plus ion. Therefore equilibrium moves forward. It means re-establishment or adjustment of equilibrium is taking place, but there is no change in pH. That is why this mixture of this solution is considered as buffer solution or change in resistance solution. Okay, a change in pH solution we can say.
Then why
Resisting in pH. Huh?
Why will we add CH3CO?
What is the use of this? See, if you add H plus ion, what happens? Equilibrium goes backward. But with what help it will goes backward? It required this acetate ions now. From where it will come? If you won't add this,
Already it will be present.
already it has. But how many it will be having? Like same quantities here, but you are adding extra quantity of H plus ion. That has to be consumed now. By what ions that will be consumed? This acetate ions. From where you will bring that? If you won't add this. So this is what is this is the use of adding
Salt.
salt. So by addition of the salt, whatever the H plus ions you are adding, that will be taken or consumed by this acetate ions and goes backward. Is this clear?
OH minus.
If we add OH minus, simply this H plus ion will consume that OH minus. It means equilibrium comes.
Then no effect of CH3CO.
That time no effect, that time no use of acetate ion. Okay, right. Clear now, concept is clear now? Right. Now what I told you, if I say at equilibrium, like initially C is the concentration, this will be 0, 0. After some time I told you C minus X, this will be X and this is also X. Now I told you that if this is 0.5 concentration, these ions are also 0.5 and 0.5 from strong electrolyte. Right now.
So X is
So what you can write, total acetate ion concentration means what you will write?
0.5.
X plus 0.5. This is nothing but 0.5. It means 0.5 is the acetate ion concentration coming from salt only. So now look at here, concentration of H plus means I can write Ka multiplied with acetic acid. Simply I am writing acid by acetate ion. Instead of writing acetate ion concentration, from where that acetate ion concentration is taken here, 0.5 means that is purely from
Basic salt.
salt. So I can write here concentration of salt. So concentration of H plus means Ka plus acid concentration by salt concentration. So apply minus log on both sides, minus log of H plus, this side also minus log of Ka into concentration of acid by concentration of salt. So minus log of H plus means pH. This is this term becomes pKa. See, log of this thing is there. So I can write plus log of salt by acid. How I am writing this? Yes. So that means negative will be removed here. So is this clear? So we got pH of acidic buffer. Done. Similarly, what is the other combination I told you?
Basic buffer.
Basic buffer. So now, in the case of acidic buffer, what concentration you got? H plus ion. In case of basic buffer, you will get OH minus. So this derivation all I will be giving you as a work, but final output I will tell you here itself by using or by utilizing this acidic buffer. See, previously we got H plus ion concentration, here we will get OH minus. So OH minus ion concentration will be equals to what? There it is equals to Ka, here it will be equals to Kb multiplied with concentration of salt, I mean see
Base.
acid by it's anion we got. So I can write
Base by salt.
base by salt. Okay, next. So minus, if you apply minus log on both sides, what will be happen?
POH.
So it will become POH, this will become pKb plus log concentration of salt by concentration of base. That's it. This is about POH. Now if I ask pH for basic buffer, what to do? 14 minus POH. Find POH first, then do it 14 minus POH to give pH. One more type of salt I told you. What is that salt?
Simple buffer.
Salt buffer. So in that case, what is the formula you will be using? Tell me.
pKa plus pKb.
what is that mixture combination you have seen?
Weak acid plus weak.
Salt of weak acid plus
Weak.
salt formed from weak acid plus weak base. So that is nothing but simple example. You take one example first to understand it more clearly.
NH4OH, CH2C.
What is the salt formed?
Acetate ion and
Ammonium ion. So it's a salt of acetate ion and ammonium ion. Right now. So now that is nothing but a simple salt hydrolysis formula we can use now. What is the simple salt hydrolysis formula for weak acid weak base combination? 7 plus
7 plus half
into
pKa plus
pK minus
pKa minus pK.
pKb, that's it. So you can write a salt buffer and write the pH formula also. Okay, write a question. Write a question after this. Find the pH of a solution formed by mixture of 3 moles of acetic acid, formed by mixture of 3 moles of acetic acid and 1 mole of NaOH, sodium hydroxide, NaOH. Simple question. 1 mole of NaOH. Given Ka equals to 10 power 5. So like this they will give the question by giving Ka value or pKa values. Got the answer?
Yes. 1 mole, both 1 by 3.
What is the formula?
pH equals to pKa plus log salt by
Log concentration of salt by
concentration
of acid. Okay. So now first of all find the concentration of salt. Did I give in salt concentration? Simple. First write basic reaction. Acetic acid plus NaOH. 1 mole gives 1 mole. Acetate ion, sodium acetate ion. Okay. So acetic acid how much I given? 3. NaOH how much I given? 1. So it means which is limiting reagent here? NaOH. That will decide how much amount of salt is formed. So from that how much amount of salt is formed? 1 mole is formed. How much amount of acetic acid is remained unreacted? 2. That's it. So you got concentration of salt is how much? 1. Concentration of acid is how much? 2. That's it. So pH will be how much now?
6.4.
So pH will be pKa value is how much? Ka is given as 10 power minus 5. So pKa means log minus log of Ka, that will be 5. So pKa plus log salt by acid concentration. So 5 plus log salt concentration is how much?
1.
See 1 mole of base plus 3 moles of acid is given. So out of that limiting reagent is base. So 1 mole of salt is formed from that. So salt concentration is 1 and acid concentration remaining out of 3 moles, 2 moles are remained. So that's it. So 5 minus log 2 I can write. Yes or no? Yeah. So log 2 value is how much? 0.3. That will be 4.7. This will be the pH of the resultant solution. Is this clear or not? Yeah. So now buffer capacity is one more term we have. What is that I am saying? So a solution, now what is the definition I have given for you? Buffer solution means solutions which resist the change in pH by addition of small amounts of acid or a base I am saying. If we add greater amount, they loses their resistance, they loses this capacity right now. So buffer capacity will be varies from pKa plus 1 to pKa minus 1. So I can simply make pKa plus or minus 1. This will be the buffer range. Okay.
So we have to do log 0.5 as 5 into 10 to the power minus 1.
What?
చేయొచ్చు కదా 6 వస్తుంది 4 7 రాట్లేదు లైక్ ఇప్పుడు లాగ్ 1 0.5 వస్తుంది ఇది సాల్వ్ చేస్తే సో
Okay, next. So now just look into your modules. There will be some questions related to buffer solution. Solve all those questions. The next class we will discuss about solubility and solubility product. Very important topic for both JEE and NEET. Okay, do not skip this. Okay. Is there any doubts?